The question is, which of the following is not the property of equipotential surface? So we are having four options here. They do not cross each other. The rate of change of potential with distance on them is zero. For a uniform electric field, they are concentric spheres. They can be imaginary spheres. Let us discuss each one, and let me quickly show you that this is from electric potential and capacitance in class 12th physics NCRT. So in that I have noted few points that an equipotential surface is a surface. An equipotential surface is a surface with a constant value of potential at all points. So on equipotential surface, we will have a constant potential everywhere on the equipotential surface. Equipotential, the potential is same, and from this point we can understand that electric field is always perpendicular to the equipotential surface. So electric field is perpendicular to the equipotential surface, and here we have a equipotential surface for a single charge, and this is equipotential surface for a uniform electric field. So again, let me explain you each property. So here they are asking what is the property, they are not asking what is the property of electric potential equipotential surface. They are asking what is the, which of the following is not the property of equipotential surface. Now we have to find what is not the property of equipotential surface. Let us divide it. Now first one, they do not cross each other. So if the equipotential surfaces cross each other, let us suppose this is a equipotential surface and this is another equipotential surface. Now they are crossing each other. So when two equipotential surfaces cross each other, just now I told you that the electric field is perpendicular to the equipotential surface. Now at this point the electric field direction is like this. Now this is for the electric field for the first potential surface, equipotential surface. For the second equipotential surface, the electric field is like this. So at a single point, we are having two directions of electric field. At single point, two directions of electric field. So you know very well that it is not possible. So though they do not cross each other is the right answer. Now second option, we will go with second option. Now we will go for second option. What is the second option telling? The rate of change of potential with distance on them is 0. So the rate of change of potential with distance. So that means dV by dr, they are talking this quantity. Rate of change of potential with distance. That means they are talking about dV by dr. Okay. They are talking about dV by dr. Now this is 0, they are telling. I told you this is a equipotential surface. So at this point the potential is V, at this point the potential is V, because everywhere the potential is V. So dV means, what is dV? dV means change in potential. When the potential is constant, the change is 0. So dV will be 0. So dV by dVr will also become 0. So this is also a right answer. Now we will go for third option. Before going to third option, let us quickly go to fourth option. They can be imaginary spheres. Here you see the equipotential surfaces you see for a single charge, they are imaginary spheres, right? See, this is a single charge. Equipotentials for these surfaces for this one are, see, spheres, concentric spheres. So this is also a right answer. Now we are left out with only one option for a uniform electric field. They can be concentric spheres. Now let us see what about this option. Okay, let us see what about this option. For a uniform electric field, they are concentric spheres. Now let us draw concentric spheres. 1, 2. Now these are concentric spheres. Now what I will do is, I will draw electric field lines for them. So electric field lines will be perpendicular to the potential equipotential surfaces. Now see, I am drawing the electric field. Now the electric field is radially outwards. Okay. Now the electric field, is this electric field is uniform? No. Uniform electric field कैसे होता है? How the uniform electric field will be? How the uniform electric field will be? It will be like this. The electric field lines in a uniform electric field lines are parallel lines. Okay. So for a uniform electric field, they are concentric spheres. They are not concentric spheres. Okay. So what is the actually the equipotential surface for a uniform electric field? You see, it is there in NCERT. The equipotential surface are as shown in the figure. But what they are telling it is concentric spheres. So it's a wrong answer. So the choice of this one is third option. Next, we will go to the second question. 2 point charges plus 8q and minus 2q are located at x equals to 0 and x equals to L respectively. The point on x axis at which net electric field is 0 due to these charges is. Now let us draw an x axis. Let us draw an x axis. So this is the x axis. This is origin. Okay. Now this is, let us suppose, L distance. Now here there is a charge plus 8q, because plus 8q at x equals 0, minus 2q at L distance. So minus 2q at L distance. Now what we want is, we want that the point on x axis at which net electric field is 0. So let us take some 2-3 locations. Let us take 3 locations. What are the 3 locations we will take? Let us take in between A. We will take A, and we will take here we will take B, here we will take C. Okay. Now what will be the electric field at A? We are just finding out whether there is a chance of electric field becoming 0 at A or at B, at C. First let us find out. Now at A, what happens? What happens at A? What happens at A? See, I will tell you one simple logic. Whenever you will want to find electric field at a point, you just imagine that you are keeping a unit positive charge there. So let us keep a unit positive charge here. Now what this plus 8q will do that to that one? It will repel this one because of the simple same charge. Now what minus 2q will do to it? It will attract to this one. That means both the forces at A, both the forces on the unit positive charge kept at A are in the same direction. So when they are in the same direction, they will not cancel each other. So there is no chance of electric field becoming 0 there. Now at B and C, 2 locations are there. First let us find at B. Now again you keep a unit charge here, unit positive charge here. So plus 8q will repel this one and minus 2q will attract this one. So the two forces are opposite. Yes, there is a chance of electric field becoming 0. But if you observe clearly, the location of point B is very close to plus 8q. That means the 8q is a big charge because its magnitude is more. So it will repel very strongly, but minus 2q is a small charge, one thing, and second thing is very far from the location at B, unit positive charge at B. So the chances of electric field at becoming 0 at B is 0, very minimum, is not there, very less chances, because 8q is very close, it is repelling very strongly. 2q is very far, it will attracting very weakly. And now we are left with only location C. At location C, if you keep a unit positive charge, what is happening is minus 2q is repelling this one, and plus 8q is plus 8q is repelling this one, and 2q is attracting this one. C, 2q is the force on the unit charge at C due to minus 2q is less because of the magnitude of the charge. At the same time, 8q is repelling this one, and this force also is minimum due to the location, because the location of C is very far from plus 8q. So what I want to tell you is the chances of electric field becoming 0 at point C is more. So we will go with point C. So let me draw again the same thing. This is O, where plus 8q is staying, and this is at a distance L where minus 2q is there. Now this is point C where we are going to find electric field. So we have to imagine a unit charge, positive charge here. Now electric field, so plus 8q is repelling this one, and minus 2q is attracting this one. So these two should be balanced. So let us balance them. So इलेक्ट्रिक फील्ड का फॉर्मूला है 1/4 पाई एप्सिलॉन नॉट. इलेक्ट्रिक फील्ड का फॉर्मूला क्या है 1/4 पाई एप्सिलॉन नॉट q/r². So here charge is 8q by what is the distance of 8q from O to C. So let us suppose this is x. So from here to here L. So L plus x whole square equals to 1/4 pi epsilon naught 2q by x square. So this one get cancelled, 2q into 4 है. So you are left with 4 by L plus x whole square equals to 1 by x square. So when you do square root and all, what you will get is x value आपको L आ जाएगा. But what they are asking? They are asking the point on x axis at which the electric field is 0. So from origin you have to find the distance. So from origin अभी इधर तक L है, and from here to here it is again L. So the answer is 2L. Okay. Next we will go with fourth question. The electric dipole moment. The electric dipole moment P is placed parallel to an electric dipole of dipole moment P is placed parallel to the uniform electric field. The amount of work done in rotating the dipole by 90 degrees is. So again this is from the same chapter. इसका फॉर्मूला है माइनस पी cos theta 2 minus cos theta 1. Now what is theta here? Angle between P bar and E bar. Theta is angle between P bar and E bar. Now theta 1 कितना है, theta 2 कितना है? Theta 1 initially what happened? Parallel. Initially parallel means what? Parallel means angle is 0, and rotating the angle, rotating the dipole by 90 degrees. So finally it should be at what angle? It should be at 90 degrees. So W equals to minus P cos 90 minus cos 0. So, minus P cos 90 0, cos 0 1. So, minus P into minus 1. So, answer is P. I hope you understand this one. Okay. Next, we will go to the next question. 3 capacitors, 2 microfarad, 2 microfarad, 3 microfarad and 6 microfarad are joined in series with each other. The equivalent capacitance is capacitors in series. उसका फॉर्मूला है sorry 1 by Cs equals to 1 by C1 plus 1 by C2 plus 1 by C3. So, actually this is reverse of resistor. Resistor series is R1 plus R2 plus R3, but resistors parallel 1 by Rp equals to 1 by R1 plus 1 by R2 plus. So, their parallel formula and capacitor series formula are same. So, again 1 by 2 microfarad plus 1 by 3 microfarad plus 1 by 6 microfarad. So, what you will get? LCM 6 microfarad, here you will get 3, here you will get 2, here you will get 1, 3 plus 2, 5 plus 1, 6, 6 by 6 microfarad, that is 1 by C series, 6 get cancelled. So, 1 by 1 microfarad. So, capacitance series is 1 microfarad. So, the answer is 1 microfarad. Next.